Hello, this is going to be over the Unit 5 review, or I could say practice test. It's formatted very much like your test. There may be a couple of additions on the test to keep things simple for me. I am going to go through the whole thing in one video, but please know I will have told you in class that you are only responsible for certain questions, that at least this term we are splitting this into two parts due to a holiday and some snow days and things like that. All right. So first part, exponential equations. So exponential equations, I hope that you remember that we must have the same base, all right? So if we don't have the same base, we can't just jump in and start trying to solve. So first we have to find the same base, and typically that means we're going to have to go down to a smaller number. So here on the left, I see 125 and I see 5. So I want to think to myself, is 125 a power of 5? And hopefully my answer is yes. And yes, 125 is 5 to the third power. You might say, what if I don't know that? Well, then you want to experiment on your calculator to figure out that. And then your calculator is going to be absolutely necessary on this test, not just for this kind of problem. And then it already has an exponent up there, so that's still going to be there. And then this is also important. The 5 is the base. What is the exponent if I don't see an exponent? A 1. So I need to think about that being 5 to the first power. And then the 5s, the bases are going to drop. And what we're going to be left with is 3 times negative x minus 2 is equal to, not 5, 1, because we're working with the exponents. So then negative 3x minus 6 is equal to 1. And then I'm going to finish and solve that. Don't be surprised. We are probably going to get some messy answers up here. So fractions here, please normalize their presence. It's okay. So 1 plus 6 is 7. I need to divide by negative 3. And so that's my answer. Negative 7 over 3. The negative could stay with the 3. It could be moved to be with the 7 or just out to the side, but that's how I would leave it. If you want to give me negative 2.333, okay, but I would just leave it in a fraction. So in number 2, is the larger number a power of the smaller number? If I do 36 to the second power, that's more than 216, so no. So this means we have to change both. And hopefully we at least recognize that 36 is 6 to the second power. Then I might say, I wonder what 6 to the third power is. And remember, we're using that caret button. So if I use that on my calculator, ta-da, we find out that is 216. So this is now 6 to the third. But this one already had an exponent of negative 2x plus 2. Use some parentheses because you're going to distribute that. It is not 2 minus 2x plus 2. Now our bases are the same. Once they're the same, we can eliminate the bases or drop them. And now that becomes our equation, the exponents. So our equation, they're called exponential equations because the equation comes from the exponents, only after the base is the same. So I distribute it. Now I'm going to subtract 4 on both sides. and divide by -4. Two negatives do make a positive, so please be sure to clean that up and give me a positive for the answer. All right, so as you see, and if I'm showing you some with fractions, then you probably will have at least some fraction answers also on the quiz. So watch your steps, because just because it's a fraction doesn't mean it's the right fraction, but please don't second guess your answer just because you see a fraction. All right, and now this last one. I have a fraction, so I know this is going to be a negative exponent. And then is 9, the number in the denominator, a power of 3? Yes, right? 9 is 3 to the second, but it was in the denominator, so that's 3 to the negative second. Left side is staying the same at this point. Then we're going to drop these bases. And I have 1 minus 2p is equal to -2. And we need to get everything to the same side. So -2p is -3, divide by -2. So I could leave that positive 3 over 2. I might say 1.5. Over here, maybe you would say 0.25. Here, this one's going to be messy. If you change it to a decimal, it would be repeating. All right, so those are our exponential equations. Part 1. All right, this problem on the bottom of the page is also an exponential equation. But it's asking you to describe the mistake in the work, and it also asks for the correct answer. So whenever I get something like this, I try to just go with the original problem and go over to the side and work it myself, and to try to not be influenced by what they did. Because somewhere over there, I promise there's a mistake. And if you just look at it, you might just go, and not find the mistake. So first thing I'm doing, I just rewrote the original problem, and then I need to have the same base, just like you did above. And I see that 8 is 2 to the third power. And then I'm multiplying that times 2n. Also, the reason I'm doing this is I have to get the correct answer also. I think below what you can see, that's what it says. So the 2's drop. So -3n plus 7 is 6n. And then I want those n's on the same side, of course, so I'm going to add 3n. So now I have 7 is 9n. And I need to divide by 9. So n is 7 over 9. So there's my answer. And now, as far as what is the mistake, I'm going to go back through their work and see the first time my work and their work is not the same. And so when I do that, I see that way early in the process, right? In step 1. And so that's what I'm going to say. I'm going to say in step 1, they or he or it says 2 to the fourth power, or maybe I should say they replaced 8 with 2 to the fourth power. 8 equals 2 to the third power, not 2 to the fourth power. And we don't have to go on and say the rest of the things that are different, because of course they're different. because they don't have step 1 right. All right, or you could say the exponent on the 2 is wrong, or there's more than one way you could identify that. At the bottom of the page, that was simply your place to indicate that answer. And then on the top of the next page, this is just asking you to change it to a different form. All right, so, and it's multiple choice, it's not 4 questions. So it may be helpful to look at your reference page, right? You could look at your reference page, and then you would see, for example, that this is where the B is, this is my Y, this is my X, if I want to think about Y equals B to the X. Keep in mind that could also be B to the X is equal to Y. So my base is 15. So as soon as I identify that my base is 15, I know no way is this the right answer, and no way is this the right answer. And then which one should be the exponent? The exponent is the one on the other side of the equal sign in log form, the negative 18. So I choose this, and I move along. And then here, this is a true statement. 8 to the negative second is 1 over 64. Which one is the base would be the first thing I would ask myself. The base is the 8. So then when I look at the choices, if there is only one choice where the base is 8, I choose it and move on. All right? So a couple multiple choice questions in there. Again, you will see on your reference page to help remind you with the placement of things, but you're just choosing the correct one. Scrolling on down the page, these say evaluate. So again, evaluate, value. We should get a number answer. And personally, I think to myself here, I know that 7 to the 3rd power is 343, so this is equal to 3. That's what I'm looking for. If that is not obvious to you, that's okay. Then you just change a base, right? We can use change a base. There's another way, but for some of you, this is going to be the quickest, easiest way. So you're going to do log of 343, divide it by log of 7, and again, you're going to get 3. All right, so number 8, again, you could go straight to change of base, log of 2, divided by log of 8, or you could make an exponential equation out of this, saying 8 to some power is equal to 2. And then it would become a problem like the front side of the page. If you use the calculator, you're going to get 0.3333, a whole bunch of 3's. Or if you use the equation, you might say 1/3. Either of those answers, this or this, are okay. And then here, some of you are just going to look at that, and you are going to know that 3 to the 4th power is 81, and that it's in the bottom, so it has to be negative 4th power. Because, and this is what I'm thinking, this is equal to this. If you're like looking at that like, how in the world would I know that? Change a base still works, but you're going to do log parentheses 1 divided by 81 to put in that 1 over 81, and then that divided by the log of 3. And again, negative 4. Same answer. All right, so lots of questions, but again, things on your reference page, change of base is on your reference page. You can use that. Should be very helpful. And then here we are expanding. So again, reference page, expand means it's going to get bigger. So I see two variables. So I know I need my log and my base 2 times. One of those is for A, one of those is B squared. It's multiply, so multiply goes with add. And I'm almost there. Now the squared is going to jump in the front. And sometimes I just put it here and then erase the one that's over here. So I'll go ahead and write it in another step for you. And some of you may do that step at the same time. Final answer. All right, so when I'm grading these, I'm looking for, did you use plus because it was multiply? Do you have log base 5 2 times? Do you have the A and the B? And did you move the 2 to the front? So lots of points for small steps. Here, how many different variables? 1, 2, 3. So we will have log base 7, and every one of those logs gets that base. If it was a common log without a base written, then they wouldn't need it, but it's not. And so this first one is just x. They are all being multiplied, so it's going to be pluses in between. This one is y, and that second power, remember, is going to jump over here. So I'm just going to go ahead and write it in the front. Kind of shorten things up just a little bit there. Again, if you want to write it like I did above first. And then this last one, I need to move my plus sign because the 4 needs to go in front of this log that is for the z. So each factor in there gets its own log base 7. Now, fractions indicate what operation? Division, that's right. And division goes with subtraction. So h is going to get a log base 8, and w is going to get a log base 8. Oh, base 8 for w, sorry. And then whether you do it in a separate step or maybe you just move the 4 to the front, but this is what your final answer should look like. Okay, so those were expanding. We made things bigger. We used, each factor had its own, each variable had its own log. So next page, we're going to go to the opposite direction. Now we are going to condense the logarithms. So now we're going back, condense. We're only going to use the word log once. Still has to have the base. And this is subtraction, so it's going to go with division. And I'm going to put that inside a parenthesis. Just like that, it's great. If I could divide that, I could make it, I could divide it, but in this case, 7 over 10 is wonderful. So here, log base 2, the top is 3. Remember, the 5 is going to jump back on. So 3 to the 5th power over x to the 4th power, because that's jumping on here. And then since we can evaluate 3 to the 5th power, we should do that. So log base 2 of 243 over x to the 4th. I can't actually divide it because the bottom is a variable. And then down here we have a series of things, and they are all addition. So addition goes with multiplication. So we're condensing. And then and this guy, my exponent, is going to jump on here. So I have 3 times 4 times x to the 11th. And then if I can kind of tidy that up a little bit, like by multiplying 3 and 4, So 12x to the 11th, like that. Final answer, final answer, final answer. All right. Again, bottom of your reference page gives you some examples of condensed and expanded form. If it says condensed, then you're condense in the directions, you're already in expanded and you are moving back to condensed. If it says expand, you are in the condensed column and you're moving to the expanded column. And then here's just a multiple choice for the same thing we just did. So I know that this plus means these two are going to multiply. And as soon as I know that, actually, I need 8 times x because they multiply. And then this part is subtract, so that's why this is in the bottom. They multiply, and then this is in the bottom. I'm not even sure how you would get some of the other things, so we're not even going to talk about them. Choose B and move on. For this particular, during the term I'm making this, we will not be doing these questions on the same quiz. But for future, first off, this should say 17 to 20. I don't have an editable version, my bad. Instead of 16 to 19. I'm going to go ahead and do this, but I would advise if you are watching this and you are only taking part of this quiz at a time, you might just wait to watch this part. You could fast forward through this part. All right, so there are logs on both sides, kind of like having the same base. So we can get rid of those, and then that creates an equation from the two arguments. We have an x squared, so everything's going to need to move to the same side. So my 17x is going to become negative 17x when I move it to the left. And my minus 3 is going to become plus 3, which I can, of course, add on to my 69. So now I have x squared minus 17x plus 72 is 0. So we're going to factor what multiplies to be 72 and adds up to 17 would be 8 and 9. And then we have two solutions. I just want to make sure that I am not taking, that those are not logs of something 0 or negative. And they're not. So we're okay. Remember, there was a little bit about extraneous. They're not extraneous. They're both good. So over here, condense the logs. You can only drop them when you're down to 1 on each side. So if I condense, I have log base 4, and then this is, I'm going to multiply these, but I'm going to distribute. So 12x plus 60. Oh, I'm not going to multiply them. My bad. Shoo. And I'm not going back to get rid of my mistake. I'm going to divide them, right? Because this says x plus 5 and it says minus. All right, that's why I didn't remember doing that. Too late in the video to think about re-recording. So again, sorry about the mistake. So now that I just have 1 log on each side, remember I condensed, it was minus, so I made it division. Caught myself just in time. Then I can get rid of my logs and just make my equation from what remains. That's a big fraction, so I'm going to have to multiply first. So I'm going to multiply both sides by 12. and then subtract 5. So x is 31. All right. All right, the end is getting somewhat near. Again, some of these problems you're not going to have on the same quiz. So this is another one I would condense first. So if I condense this, that means I'm going to multiply. 10 times 7x would be 70x. And then over here, this would just stay the same. Now I can drop my logs. And then 70x, when I drop the log, the base goes with it. Divide by 70. And as ugly as that is, that's the answer, 29 over 70. Now, number 20, there is not a log on both sides. So when that happens, we need to change to exponential form. So we need to change to exponential form. So my base, so here's my y, right? And that is equal to my base to the raised to the exponent, right? This is my b, this is my y, this is my x, the way we've looked at it. So now 10n minus 9 is 81. And then I just solve that equation. So you want to go ahead and evaluate 3 to the 4th power before you try to solve the equation. And divide by 10 to get n is equal to 9. All right, so those log equations are going to be, if you're watching this during January of 2025, those log equations are going to be in your second part of this quiz. So when we look at a function, this exponential function, if the b, the base, is greater than 1, what is it called? It is called growth, exponential growth. If it was less than 1, it would be decay. All right? And now on number 22, we are going to make a graph. And in this case, it just asks you to make the graph. You will create a table using x is -2 to +2, sorry. So you'll have 5 points, and then you're going to sketch those, put those points on the graph if they fit. One of them is actually, in this case, not going to fit. So 4 to the -2nd is 1/16. As a decimal, that's like 0.00, no, too many zeros, 0.625, I believe. 4 to the -1st, that's 1/4, or 0.25. This 0 would be like here. So there is a 0 between the decimals. It's really, really tiny. 4 to the 0 power, remember this is not multiplying, we're raising it to the power, is 1. 4 to the 1st is 4, and 4 to the 2nd is 16. So there's our one that's not going to fit on our graph. So -2 and 1/16, really close to 0, but not, I mean, I'm probably drawing it higher than it really would be. A little bit higher, still not halfway. 0, 1, 1, 4, And then 2 is way off the graph, way, way up there. So when I sketch this, this is getting lower, close to the line. Don't take it under. And this should be off the top before you get to 2. I'm not asking you to aim for a certain spot, but if you do something like this and it's over here, no, because then you were saying like 3 or 4 to the third power is only 7, and that's absolutely not true. So make it go up nice and fast if it's going off your graph. And does this show growth or decay? In this case, it's not asked, but this shows growth, and your y-intercept is at 0, 1. All right, good. And then this one, oh, well, maybe I should wait and go down a little bit. So here, still going to use -2 to +2. So 1/2 to the -2, that's going to flip it and square it. So that's 4. So that makes 12. 1/2 to the -1 becomes 2. So 3 times 2 is 6. Again, practice putting this into your calculator. Make sure you're getting the same answers as I do. 1/2 to the 0 power is 1, and then 3 times 1, this is not adding, this is multiplying, is 3. And then 1/2 to the 1st, 1/2 times 3. So as a decimal, I could do 1.5. 1/2 to the 2nd is 1/4, or 0.25 times 3, 0.75. So -2 off the top, -1 is already up here at 6. 0, 3, 1, 1.5, 2, 0.75. So this one is going this way, way off. And then over here, down, 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 close, but it's not actually going under. And does this represent growth or decay? It represents decay. And you could give me a couple different reasons for that. I do explain, it says explain, not just tell. So because I could say B is less than 1, right? The 1/2 is the base, and that's less than 1. And I'll say the y decreases as x increases. So I can see that it's getting smaller. And you might say that. You might just say, I can see that the value is getting smaller from left to right. So you don't have to tell me all those things. If you just said because b is less than 1, that's okay too. All right? 5 points in your table. Perhaps all 5 will fit on the graph. Perhaps some will be off the top of the graph. And then you're going to be answering the questions. I think this actually has another question underneath. It asks us, what is the y-intercept of the graph? And you could actually get that from your graph or your table. Remember, the y-intercept will always be the one where x is 0. So in this case, that was 0, 3. Okay, so those graphing questions are part of our first part of this, because that was in the first section. The word problems are not part of the first of the first quiz. So you could stop watching because the rest of this is word problems. So if you're just ready for the first part of the quiz, you're not doing it the whole thing at once, then you could stop watching now. And many people aren't going to be watching because you're in class, and we will have just talked about it. All right, so here we are using our exponential, and we want to recognize, so we have some amount. To get our growth or decay rate, we have to do either 1 plus or 1 minus the rate, and then our time is up here. So our starting place is $3,400. Depreciated means it decreased. So I'm doing 1 minus 0.20, which would be 0.80, or I could just write 0.8, and 5 years later. So then I grab my calculator, and unfortunately I do not think this actually comes out to be one of these exact answers, which is kind of unfortunate. 0.8 to the 5th power to the 5th equal. So $1,114.12 would be the answer. I would prefer that were given over here. So my closest choice as an estimate of what the computer is worth, $1,114. Right? So depreciate it means the value declined.